So Schrodinger's quantum model of the atom leaves us with a completely different image. The atom now looks like you have a whole bunch of balloons all tied together in the center, and it's essentially a hot mess. We somehow have to be able to communicate where exactly the electrons are around the outside of an atom. And drawing, unfortunately, is really not going to be adequate to the task of showing where all of these atoms are. Because if you can kind of see the picture that's up on the screen right now, we really can only see the outer shell of the electron, so we have no idea as to the arrangement and the guts of this atom at all. So we come up with a different system, and we call it electron configuration. Now, electron configuration is just essentially a list. It's a list of how far away the shells are. So are you in level 1, level 2, or level 3? Shell 1, shell 2, shell 3. And what shape the electrons are traveling around the atom in. Are they in that S shape, that spherical shape, the P shape that looked like 2 balloons tied together, a D shape that looked like 4 balloons tied together? And again, just to remind you of what those shapes look like, here's just one little quick reminder. The S shape, just by itself, is a spherical shape. The P shape, 2 balloons kind of tied together at the center. There are 3 total shapes that are defined as P. D, there are 5 total shapes that are defined as D. 4 of them look like they're 4 balloons tied together and rotated very strangely in the XYZ axis. And then 1 looks like a P cloud with a donut around the outside. These are known as the orbitals. And an orbital is defined as a space where 2 electrons will probably be found. Our first task when we're trying to write an electron configuration is to use the periodic table in a very efficient way. So the first step is we're going to color code the periodic table into 4 basic zones. The first zone would be the S zone, and it's right here in blue. Now please notice that helium, all the way over on the other side of the periodic table, is also labeled in this same color. Even though it's separated, it's still considered to be part of the S area. Next comes the P area. Then the transition metals are labeled as D, and then the rare earth elements down toward the bottom are known as F. And ordinarily we would kind of talk about them in this order: S, P, D, F. Second, there's a numbering system on top of the periodic table. The S area is numbered at the top, starting with 1 and descending all the way down to 7. The P area starts at 2 and continues down. The D area starts at 3 and goes all the way down. The F area starts at 4 and goes all the way down. So the way that I usually remember it: S, P, D, F. 1, 2, 3, 4. S starts with 1, P starts with 2, D starts with 3, F starts with 4. So how is all of this extremely helpful in writing an electron configuration, and what does that even look like? So I'd like to show you an example using sulfur. So I'm going to place sulfur on the periodic table, and what I want to do is start all the way back at the beginning of the periodic table with element number 1, that will be hydrogen. And we're going to slowly build up sulfur's electrons, starting with hydrogen. So hydrogen's electron is a 1s electron. So we literally write down 1s. That is an electron that is spinning around in a cloud that is S-shaped, and it is in the first energy shell. I'm going to continue across the periodic table to helium, element number 2, and figure out what kind of an electron that is. That one is also labeled as 1s. So here I have 2 electrons that are both labeled 1s. So I'm going to write that very carefully as 1s2. Let's move on to element number 3. Element number 3 is in the second level. It is in the s area. So I'd start by writing 2s. I continue across the periodic table, and right next to it, element number 4 is also labeled as 2s. So I would have 2s2. Keep going across into the orange area, element number 5. That would be aluminum. That is labeled as 2 as well, but unfortunately we are now in the p area. So we have to start by writing 2p. I continue across to element 6, 7, 8, 9, and so on. They're all still labeled as 2p. Altogether, there are 6 2p's. So what I would write down is 2s2 and then 2p6. So altogether now, I've referenced the energy level, the shape that these electrons are spinning around in, and how many of these shapes I have to kind of worry about. So I have 2 electrons spinning in a 1s cloud, 2 electrons spinning in a 2s cloud, 6 electrons spinning in a 2p cloud. We continue because we haven't hit sulfur yet. We go on to the third level, and we make a list of any shapes that we have kind of going across the periodic table. So next I would write out 3s2. I continue across and I would hit 3p, but in this case, to get to sulfur, we would include the box that sulfur is in. I would collect 4 3p boxes along the way. So I would have 4 electrons in a 3p system. So this atom has 3 energy levels 1, 2, and 3. There are 2 different kinds of shapes on the inside of it, S and P. And by writing out this electron configuration, you actually know how many electrons are in each one type of these clouds. This is actually much, much better than trying to draw a picture of the quantum model of the atom. This gives us a bit more of a clear picture of what we're looking at.